Hello class. Today what we're going to talk about is how to model real-world information with polynomial functions. So given a bunch of real-world data, how can we come up with a polynomial function that will model that data and that we can use to make predictions and things like that with. So the first thing you need to do before you can model any function is to know what degree function are you going to need. And one of the tools we use for that is finite differences. Right? And the way this works, if a function has degree of n, then the nth differences will be non-zero and constant. Okay, and conversely, if the nth differences are constant and not zero, then it will be an nth degree function. Right? So that's lovely, but it doesn't make sense until we put some numbers with it. Right? So here we go. We have this data. Now the first thing that we have to do is make sure that the x's are evenly spaced. Right? So here we see our x's are going up by 1 on each time. So that's good. That'll work. It doesn't have to be 1 as long as it's the same spread every time. So if it goes up 2, 4, 6, 8, that'll work. If it goes up by 5s, it's good. Right? But if you have x of 1, x of 2, x of 7, x of 32, x of 19, that's no good because it's not going up by the same amount each time. But this is all going up by 1, so this is good. We can use it. So what we're going to do, step 1, we're just going to write down all of our data, okay, x's and y's. Mostly we're just interested in the y's. Right? So this is what we're looking at. We're looking at the y values, and what we're going to do is we're going to take the difference of all the y values. So 4 minus 1, 10 minus 4, 20 minus 10, 35 minus 20, and so on. Right? So here's all of the differences in our y values. And these are called the first differences because this is the first time we've done this. Now, if these were all the same, then if all of your first differences were the same, then you would have a first degree function. So it would be a linear function, right? Because it goes up by the same amount. It's constant slope. But that's not what happened here. So we're going to do it again. We're going to take the difference of 6 minus 3, 10 minus 6, 15 minus 10, 21 minus 15, 28 minus 21. And since this is the second time we've done that, we call these the second differences. And if they're the same, it's a second degree function, so it'll be quadratic. But if we look over here, we see they are not the same. So it's not second degree. Do it again. 4 minus 3, 5 minus 4, 6 minus 5. And these all come out as 1s. Right? So here they are all the same. And since this is the third time we've done it, it's called the third differences. And we will have a third degree function. Right? So that means our function for this data right here is going to be cubic. Now, the other thing, since this actually does work, what that means is this data can be matched perfectly with a cubic function. So what we're going to do with this is we're going to take our data right here, and we're going to put it into the graphing calculator. Okay. If we had x-intercepts given to us, then we would do other things. But since we don't, this is what we're going to do. So I'm going to set this right here. So to put this into our calculator, okay, I have an TI-84, works on 83s and 82s. If you have the newer things, you got to figure out where to put them because I don't have those. So we're going to hit Stat right here in the middle. And we want to edit our list. So we're going to go to Edit. And what you want to do is put your x's in L1, put your y's in L2. So I've already got those in this. So if you want to pause the video real quick and type these into your calculator. And now, what we're going to do to get our equation, we go back to the Stat button. And this time, though, we want to go over to Calculate. So we're going to arrow over to Calc. And if you'll notice right here, starting at option 4, we have these regression functions. We have linear regression, quadratic regression, cubic regression, quartic regression. And that's what this third difference is good for. It tells us, hey, we get the third difference, so we want to use the cubic regression right here. We're going to have a cubic function. So we hit Enter. And I've got other things in there. I need to fix that. So my X list is coming off of L1. My Y list is coming off of L2. And I'm just going to arrow down here, calculate, and there it is. So here we see our function. This is a cubic function. It's in standard form, ax cubed plus bx squared plus cx plus d, right? And it gives us our values, a, b, c, and d. All right? And there it is right there, so you can see that. Okay, if yours has it, this r squared at the bottom, that tells how closely it matches up. And what you want is a 1. That means it's perfect. My calculator doesn't have that, so oh well. All right. Now, what we're going to do with this is we're going to take these and 0.1666666, that's 1/6. So we can write that as a fraction. 0.5 is 1/2. Repeating 3 there, that's a third. So here's our function. F of x equals 1/6 x cubed plus 1/2 x squared plus 1/3 x. And then our constant is 0, so we don't mess with that. There it is. So easy enough. We do the finite differences to find out which degree we want, and then we put it into the regression. So not a big deal. What I would like for y'all to do is this one. So if you would, pause the video and see if you get what you get. Put it into the regression, see what you get. Alright, so let's see how you did. Here you go, there's the answer. This is a third degree function. And we have negative x cubed minus 7x squared minus 7x plus 21. And just so you can see the finite differences, first differences, second differences, and here's the third differences, and those match up, so that's what it is. Right? And so you should just put this in your calculator, do the regression, not a big deal. Alright, so here's a question for us though. This shows the total U.S. biomass energy consumption in trillions of BTUs for the year, where year 1 is 2001. What we need to do is find a model for this, a polynomial function, and then use that to estimate the U.S. biomass consumption in 2013. Okay, so this is real world data, and if we do the finite differences, which I've got over here, you'll notice I did first, second, third, fourth, fifth, sixth, and it's not coming out, and it ain't gonna. This is real world data. The finite differences only works if the data will match the function perfectly. And as you know, nothing in the real world is perfect. The real world is a mess. And so finite differences aren't going to help us. We're going to have to do something else. So what we're going to do is we're just going to take these numbers as they are and put them straight into our calculator. Not going to mess with any of this. All right, so open up your calculator. Move this out of the way. Pause the video, put this into your stat list, and then come back. Alright. So I have my data in here. I put it in L4 and L5 so I didn't have to delete the other data. You go ahead and put it in L1 and L2. Alright. It'll work out better that way. It's a lot easier to deal with. Okay, and what we're going to do first is we are going to make a scatter plot with this data. So go to y equals, just arrow up to plot 1 and turn it on. Alright, so plot 1, hit enter, and that should work. If you put your data in L1 and L2. If you didn't put it in L1 and L2, then you have to go to the stat plot and you'll have to change your settings, but that's fine. If you put it in L1 and L2, you probably just got to turn it on. Alright, so you graph it, and I've got nothing there. So we hit zoom, and if you notice, these numbers are all pretty big. 2,600, 4,300, and come down here to zoom 9, that's zoom stat, and if you hit enter, that will automatically fix your window to match what you have in your stat lists for your stat plot. And so there it is, there's our scatter plot. And what we're going to do is we need to look at this scatter plot and try and figure out what kind of function will this be. Is this linear? Is it quadratic? Is it cubic? Is it quartic? What is it? And looking at this, it might possibly be linear, but we see it does turn down right here and does have a little bit of a curve to it here. So probably more along the lines of a quadratic, not a quadratic, a cubic function. You've got to curve up and then curve back down. So that's what we're going to do. We're going to do a cubic regression here. So stat Calc, go down to Cubic Regression, and don't just hit Enter all the way down on this, okay? I'm going to change mine to L4 and L5 real quick. You can leave yours as L1 and L2, that's fine. But what we want to do, see this line here where it says Store Reg EQ. What you do here, go to Vars, which is right here next to the clear button. Arrow over to Y Vars, Y variables. And we're going to put this into a function. So hit Enter on function and put this into Y1. So hit Enter again. And then arrow down and go to Calculate. So there's our regression equation, and notice this is a mess because the real world is a mess. We've got lots of these lovely decimals and stuff like that, very long, messy things. If yours happens to have the R squared, you notice it is very close to 1.988. So this is a very good approximation. All right. Now, what we're going to do with this, the reason we did that Y var stuff, if you hit your Y equals, you'll see there's your equation right there in your Y equals, and you didn't have to type it in, you didn't have to round it off. It's got all 10 decimal places, and so it's good. So now when we hit our graph, we can see, and that matches up with our function, with our scatter plot, very, very closely. All right, so this is a really good approximation. All right, and there's that. Now, so this is our function right there. And we have to round it off when we write it in because that's too much. So we round it off there. Here's our function, but it wants us to also use this to predict energy consumption for 2013. Now, obviously, this is old, but it's going to estimate, it's going to get it for us. So what we're going to do, pull this up. We want to know 2013, so that would be x equals 13. So the easiest way to do that, it's second calc, and that very first one is value. So hit Enter, and we just want to know what is x of 13. We just hit 13 and type Enter, and there it is, right there. X of 13 is a y of 4,384.7677, and so on. All right. So there it is. So the U.S. approximately used 4,385 trillion BTUs. All right, so we come up with the function with the regression equation. Use the regression functions in your calculator. Gives us a polynomial function, and we can use that to make estimations and things like that. Okay. So what I want y'all to do is these two here. Pause the video, put these in the stat lists, look at the scatter plot, figure out what degree function it's going to be. Is it linear, cubic, quartic, quadratic? What is it? And then do a regression. All right. Not going to make any predictions. Just get the regression equation. All right. So pause the video and then come back. All right. You're back. Let's see how you did. So for number 4, this is what it gives us. So it's saying it's a cubic function. Let's take a look at that. And so here is the data. And here's the cubic function. We see how close that matches. And I went ahead and did a quartic function, and that one seems to match quite a bit better. So the function they gave me in the key, I'm thinking not so much. That's wrong. This is a much better function, except that should be a 4, not a 2. That's a problem. So that should be a 4 right there. Should be to the x to the 4th. So there's a typo there as well. Lovely. But yeah, this one is definitely going to be a quartic function. And for function number 5 here, here's the raw data. Here's a cubic function. Here's a quartic function. So you see this does match it quite a bit better. So there's our answer there. And that's really all there is to it. You take the data, try doing the finite differences. If that doesn't work, then just do a regression equation. Try it with cubic, try it with quadratic, try it with quartic, see what fits best. All right. And that's it. Hopefully that helps, and I will see you next time.